Hi, my name is Ray Ross. I am a Algebra 2 student at Martha Lane Collins High School, and today I'm going to talk to you about trying to determine the maximum profit in my fruit truck. So I created a scenario where I was going to compare honey buns and cookies, and I found that my cost for honey buns were 80 cents and my cookies are 29 cents. I plan on selling the honey buns for $1 and the cookies for $4.50. With the oven rack only having 3 racks on it, it can only make 36 cookies in 1 hour. So for our 2-hour shift, we will only have 72 cookies to sell. A constraint or limit that we have is the maximum amount of items we can sell, which is 192 honey buns in a 2-hour shift due to the refrigerator only being able to hold 32 boxes of honey buns with 6 in each box. As I said before, our goal is to determine our maximum profit. So what I'm going to explain next is the process to determine the maximum profit. The first thing you'll need to do is to write your inequalities based on your constraints. I first identified the 2 items I was going to talk about. I used H for honey buns and C for cookies. The next 2 inequalities that I have is H greater than or equal to 0 and C is greater than or equal to 0. You have those inequalities because 0 is the least amount that you can sell. We have to sell more than 0 honey buns, for instance. The next inequalities are based on all of what I had in my word problem. My first constraint is that we will only be able to sell 72 cookies in a 2-hour shift, so C is less than or equal to 72. My other constraint is H is less than or equal to 192 because we'll only be able to sell 192 honey buns in a 2-hour shift. After I wrote my quantities, I went to Desmos.com to graph them. So I had 4 inequalities as I just talked about. I'm using X for honey buns and Y for cookies. So what you're looking for on the graph is the area that got shaded by all 4 colors, which is this region right here with my cursor. And it is going to be your darkest area, and for me that is what my cursor is on right now, right here. This is what we call the feasible region. That means any point in the feasible region is a solution for an option for something that we could sell. For example, we could sell 20 honey buns and 20 cookies. But if we were wanting to determine our maximum profit, we need to identify our vertices. Our vertices are listed here. They are the corners or the points of the lines where they are intersect in our feasible region. As I move my cursor around the feasible region, the vertices are the points around them, such as 0, 0, 0, 190. I have 4 vertices as you can see in the picture. After you find your vertices, we will write an objective function. Our objective is to maximize our profit. So I wrote a profit function based on our honey buns and cookies. These numbers you'll notice weren't in the actual word problem. What these numbers are the actual profit on honey buns and cookies. I was selling my honey buns for $1 and it cost me 80 cents. So when I take my sell price and subtract my cost that tells me my actual profit. Similarly, I profit 20 cents on my honey buns, so I have my objective function and my vertices here. What you do with these points and vertices is substitute them into our objective function. To remind you, X is honey buns and Y is cookies. So what this is saying is, for example, that we can sell 70 honey buns and 190 cookies. You'll substitute these numbers into the vertices to give you a profit. These will tell you how much money you'll make based on the items that you're selling. You should see that my maximum profit is $133.70, and I did that from selling 70 honey buns and 190 cookies. So you can also see some minimum profits and general profits based on specifically what we were talking about, how to maximize our profits. So to review, we have our scenario, the word problem we wrote, the inequalities written, and then we'll graph those inequalities and then proceed to write our objective function and to determine our maximum profit. Thank you for watching. I hope you enjoyed.